Welcome to ENSTBB, a school specialized in production, purification, and characterization of biomolecules. You may now be able to recognize it thanks to that giant blue ball right behind me. Today, biotechnologies are used to produce drugs such as vaccines, antibodies, or recombinant proteins. If you want to see how it works, let's go inside.
Biotechnological processes are divided in three major steps. The first one is cloning, which consists in inserting a gene in a microorganism. Thanks to this gene, the cells will produce a protein which can be used as the major component of a medicine. The second step is the culture of the microorganism in bioreactor to produce the protein in high concentration in the growth medium. This is the upstream processing, or USP. But what's recovered from USP is a mixture of different molecules, proteins, or even cells. Today, we're going to describe how to get a product ready to use from this mixture. And this is the downstream processing.
After the fermentation process, when the yeast or bacteria have produced our protein of interest, here is what we have. And the goal of purification is to get a pure and concentrated product like this one. In the bioreactor, we have our protein of interest in large quantities, but now we have to remove the other compounds, such as the cells, which are still present in the medium. We also have all the different molecules produced by the microorganism and the remaining nutrients. We may even have some contamination that we have to take care of. If we want to get a product ready to use, for example if it's a medicine, most of those particles have to be removed. We want the final product to be pure, concentrated, and safe to inject patients.
First, cells can be easily removed because they are far bigger than other particles. A straightforward method to achieve that goal is centrifugation. As the tube rotates very fast, the heaviest particles accumulate at the bottom. For example, here you have the product with the cells, and here the supernatant. Then we just have to collect the supernatant, which is free of cells.
Once the cells are removed, our protein of interest still has to be isolated from all the different molecules. All those molecules have different chemical and physical properties that we can use to isolate them.
For example, we can use the size of the molecules, the difference of charge, or the affinity with other molecules. The processes of chromatography are based on these principles of separation. Basically, chromatography consists in using a column that can specifically interact with a type of molecule. For example, if we use the separation via the affinity, the column is packed with beads, and if we look at one bead on the right of the picture, we can see that it only fixes our product of interest. So the sample is loaded on the column and goes through the column. Molecules are then separated thanks to their specific properties. The contaminants are cleared and the product of interest is evaluated. Several steps using several properties of our protein of interest are required to get a pure product.
Being an engineer in downstream processing involves developing and optimizing such processes for specific product purification, determining the speed, the volume, and the affinity of the molecule with the column. The goal is to get a pure product as quickly as possible and as economic as possible. After weeks or months of development, the whole process is ready in laboratory and just allows to purify a few micrograms of product. But it has to be adapted to get kilograms at industrial scale. And yes, here, the size matters.
The scale-up is a key step in a biotech process design. Most of the time, it's not easy to reproduce a process on bigger machines. Indeed, the geometry of the columns or the flow rates are not often suitable for industrial conditions. So, the biotech engineer task is to predict changes and adapt the process to a larger scale production. In industry, purification process represents almost 50% of the production cost. So optimization of the purification is a major issue for biotechnological companies.
ENSTBB is one of the most fully equipped schools in Europe in the field of purification. Most of the machines you can see here are used by the industrials. Once they graduate, several students are hired in the industry as DSP specialists. They may even become developers of new technologies with the suppliers of purification tools. So if you're interested in this innovative field, if you think you could achieve what is yet impossible, come and live your dreams at ENSTBB, the place to be.